Hi, in this video we will be discussing series and parallel circuits. We will also be demonstrating how to calculate the resistance, current and voltage when the resistors are connected in series and parallel. There are two ways in which resistors or light bulbs can be connected in a circuit. It can either be connected in series or parallel. Before we start the calculations, let's refresh our minds on the difference between series and parallel circuits. This diagram shows a series circuit. The current only travels one way through each resistor, hence the current remains the same. So IT is equal to I1, which is equal to I2, which is equal to I3. The voltage across each resistor divides, meaning that the sum of the volt drop across each resistor is equal to the total voltage supplied by the battery. Therefore, VT is equal to V1 plus V2 plus V3. The total resistance of the circuit is the sum of all resistors, so RT is equal to R1 plus R2 plus R3. In a parallel circuit, the voltage across each resistor remains the same, so VT equals V1 is equal to V2. However, the current divides when flowing through each branch, so IT equals I1 plus I2. The total reciprocal resistance of the circuit is equal to the sum of the reciprocal of all resistors, so 1 over RT equals 1 over R1 plus 1 over R2. This may sound a bit confusing, but once you understand these rules, you can do any calculation for any circuit.
Let's have a look at some circuits. This circuit contains resistors connected in series. So to calculate the total resistance, we know that it is the sum of all resistors. RT equals 10 plus 8 plus 6, which gives us 24 ohms. We also know that current remains the same. Using Ohm's law, we can calculate the current. So IT equals VT over RT, which in this case is 12 divided by 24, which gives us 0.5 amps. This is the total current flowing through each resistor. To calculate the total volt drop across each resistor, we use Ohm's law again. Therefore, V1 equals R1 times I1. In this case, the resistance of resistor 1, which is 10 times 0.5, which gives us 5 volts. For resistor 2, we do exactly the same. V2 equals R2 times I2. 8 times 0.5 gives us 4 volts. With resistor 3 is done exactly the same. R3 times I3, which gives us 6 times 0.5, which gives us 3 volts. The total voltage is V1 plus V2 plus V3. As we worked out, V1 is 5, V2 is 4, and V3 is 3, which gives us 12 volts. This is the total supply voltage. In this circuit, the resistors are connected in parallel. We know that the voltage across each resistor is equal to the voltage supplied by the battery. By using Ohm's law, we can calculate the current through each resistor. I1 is equal to V over R1, which is equal to 15 divided by 5, which is equal to 3 amps. Resistor 2 is done exactly the same. I2 is equal to V over R2. In this case, 15 divided by 3 equals 5 amps. To work out the total resistance, we use 1 over RT equals 1 over R1 plus 1 over R2. This gives us 1 over RT, which is equal to 1 over 5 plus 1 over 3, which gives us 8 over 15. We then swap these numbers around and it gives us 15 over 8, which gives us 1.875 ohms. To work out the total current, we use Ohm's law again. Therefore, IT is equal to V over RT, which is equal to 15 divided by 1.875, which gives us 8 amps. To calculate the total current, simply use Ohm's law. We know that voltage remains the same in parallel, so V1 equals 30 volts. Therefore, I1 is V1 over R1, which is 30 divided by 15, which gives us 2 amps. To calculate the total current, calculate the total resistance on the first branch. The 6 ohm resistor and 12 ohm resistor are in parallel, but both of them are connected in series with respect to 2 ohm resistor. To calculate the total resistance, add the reciprocal of all resistors connected in parallel first. Therefore, 1 over RT equals 1 over 6 plus 1 over 12, which gives us 3 over 12. Therefore, we swap these values around to get RT over 1, which gives us 12 over 3, which gives us 4 ohms. Then add this value to the 2 ohm resistor so that you get 6 ohms. The total current is then equal to VT over RT. To get RT, take the sum of the reciprocal again. 1 over 6 plus 1 over 15 equals 7 over 30. We then swap this around, so we get RT over 1, which equals 30 divided by 7, which gives us 4,29 ohms. Therefore, the total current of the circuit is equal to IT, which equals VT over RT. This gives us 30 divided by 4,29, which gives us 7 amps. We know that voltage divides in series, so in the upper branch, the total current that flows through is equal to I, which is V over R, which gives us 30 divided by 6, which gives us 5 amps. To calculate the total volt drop across resistor 2, simply use Ohm's law. E2 equals R2 times I2, which is 2 times 5, which gives us 10 volts. Because R2 is connected in series to R3 and R4, the voltage divides. So you have to subtract 30 volts minus the 10 volts, which gives us 20 volts. 20 volts is the amount of voltage going through resistor 3 and resistor 4. Both resistor 3 and resistor 4 have the same voltage, for voltage remains the same in parallel. Finally, to calculate the current, simply use Ohm's law. I3 is equal to V3 over R3, which is 20 divided by 6, which gives us 3,33 amps. To calculate the current as resistor 4, I4 is equal to V4 over R4, which is 20 divided by 12, which gives us 1.67 amps. We then add 3.3 amps plus 1.67 amps, which gives us 5 amps. This is the current flowing through the upper branch. Therefore, the total current is the current in the upper branch plus the lower branch, which is 2 amps plus 5 amps, which gives us 7 amps.
That is all for today, folks. Hope this video helped you get a clear idea and understanding of circuits connected in series and parallel. Keep on studying hard and remember, nothing is impossible.